Hello guys, welcome to another session. In this session we are going to look into data types and casting within NumPy. So let's start our discussion. If you are unfamiliar about the casting, then in simple term I can tell that casting is nothing but changing an expression from one data type to another data type. So in this aspect we are going to look into two types of casting. One is the upcasting and another one is the downcasting. But prior to discussing about the casting, we have to understand that the data types I have already covered in the part 1 of this course of Python refresher. But again, I will iterate some of the point about data types. So whenever we are dealing with the numeric value without decimal, then we are referring it as an integer value. And when we are dealing with the decimal digit, then we are calling it as a float value. So now the question over here is why we are using 16, 64 and different kind of number over here. So to answer your question, these numbers are representation of the bits, how many bits we are going to occupy for a particular number if we are telling it as a float 16. So that means 16 bit of a space we are going to occupy, that is bits representation within the memory. Same is the case with float 64. Here we are telling that we are going to occupy 64 bits of memory spaces. So here we are going to discuss about two kind of casting. One is the upcasting, another one is the downcasting. So what does it mean? So to understand it better, if you look into this diagram, then you can see that upcasting calls for a higher level of precision, while downcasting is causing us to lose data by reducing the precision. We will better understand with an example. So let's jump into the Jupyter notebook where we will understand this. So we are into the Jupyter notebook. Now we will look into example where we will create two different array, and when we concatenate two different data type array, then you will find that NumPy automatically upcasts the lower precision data type to higher precision data type, and this process is called upcasting. So let's understand with an example. Suppose that we are having an array int array, and I am going to generate with the method which we have learned, that is np dot arrange. So this will give me integer array. Shift enter. We forgot to mention over here the NumPy package, so we need to import it. Import NumPy as np. Shift enter, again do it. Now it has generated it. Now let's print it. So let's look into that, what it has given us. Array. Shift enter. Now if we will look into the types, then you will find it over the array data type. So we will get it through int array dot dtypes. Shift enter. D type it is, sorry. So it is int32. Now let's create the float array, and we will get the help of np dot random dot uniform, and we will tell that from 0 to 5, and this will give us the float array. Shift enter. Let's print the array. So to print it, print float array. Shift enter. Then you will find that it has given us the decimal digit. Now let's look into what kind of data type it has. Float array dot dtype. Shift enter. Then you will find that it is a data type of 64. So now what we will do, we will concatenate these two arrays, and we will look into the third array is being automatically upcasted this array values into float 64. So let's do it. So to concatenate two arrays, we are going to use the NumPy concatenate function, and over here concatenate, and within that we will specify float array comma, and this we are going to assign with concat array equal. Shift enter. Throws an error. I know what actually the error is. You should pass the tuple over here, so make sure that you have provided extra set of parentheses, then only it will take. Now shift enter. Then you will find that it will concatenate it. So let's print this array, what value it has occupied. So we will tell that concat array. Shift enter. Then you will find that it has both the values, the integer values as well as the decimal values. But let's look into what kind of data type. So all the values now stored as float 64. So let's look into that. So to do that, we will tell concat array dot dtype shift enter. Then you will find that it has automatically upcasted the concatenated array to float 64, and this behavior is called upcasting. So here you will see that we have extra precision added to the integer value due to upcasting. So that means there is no data loss. But whenever if we are going through downcasting, then there is a chances that from higher precision to lower precision we have chances to lose the data. So let's understand with an example. So what I am going to do, I am going to downcast this concat array to integer 64 so that it will lose the precision. Currently it has precision 64, float 64, and that is giving us the precision 64. So if we are converting it into integer 64, then it will lose the decimal points. So let me prove my point. So let's create a array called downcast, and I am going to store this concat array, which I am going to convert it as a integer 64. Earlier we have seen that NumPy automatically converted it into from lower to higher casting, that is upcasting. Now I am going to decrease it from higher precision to lower precision, and to do that we are going to use as type. So there is a method called as type, and here I will specify I want to convert this from 64 float 64 to int 64, and the moment I will run it, then you will find that it will lose this precision values. So after decimal you will find that the data will be lost. So that is what I am referring. So let's print it, downcast, shift enter. Then you will find that the first value, the decimal value is gone. Second value also we got only 2. Third value also this, and remaining you will find that this is the same value. Here we have lose all the precision. Same is the case with this one. We are not having any decimal value, we are having the integer values, and that is of type integer 64. If we will look into the type dtype, then you will find that it is a type of integer 64, and the process is called downcasting. So earlier we have seen that implicit casting, where we are going through lower precision to upper precision automatically, that is called upcasting. And when we are doing the downcasting, we need to explicitly do it with the help of as type. So just remember that as type we will use it for casting from one data type to another data type. Here we are casting from float 64 to int 64. So this is what I wanted to demonstrate you in this session. On this note, I am stopping over here. See you in the next session. Till then, bye bye, take care.